So I'm really thrilled to have Bernardo here. He's a new friend. He's the Chief Digital Officer at JD Power. I know you guys have seen a lot of JD Power today. He's going to tell you how a 50-year-old company that's been gathering essentially the voice of the customer, how they're changing to have, essentially digital stakeholders. The format will be a brief presentation, an informal presentation by Bernardo. Then he and I are going to sit and chat, and we're going to invite you guys into the conversation. So, Bernardo.
Awesome. Excellent, man. Appreciate it. Sure. So the plan is I'll show some slides, tell some stories, and then I'll sit with Mark. I joined JD Power about a year and a half ago, and I never worked in auto before. So I used to work in New York City for many years, and I moved to LA to work on JD Power. And one of the first things that I did when I went to LA is I bought a plug-in car, obviously. And you buy it there not because only you care about the environment, but because also the HRV line. And so I was there a few weeks after I bought it. I went to a mountain biking trip. And in the way back, I came back through a gas station. I took the curve probably too tight, and I hit my back tire, and I got a flat tire. So I'm in this gas station, and I'm old enough to have changed a lot of tires before. So I went out and I started looking for the spare tire, and after 10 minutes I just couldn't find it. Correct. So the guy from the gas station saw that I was kind of struggling. He came out. He was like 60-year-old or something, and he helped me out just looking for the spare tire. And after a while, just searching Google, and there was no spare tire in these cars, which is kind of weird. So the same thing. The guy, it was a Sunday, so the guy helped me out. He knew somebody that could drive a truck. He was close. After a few calls, we finally got somebody to drive to like a tow truck. So we took the tow truck. Then I started calling places that had tires. After a while, I found one open like 30 miles away, and we started driving there. So 1 hour later, after I got my flat tire, I was driving in this canyons through California with my car in the back and talking to this guy, and I got an email. And the email said, Bernardo, the email is from GM, said, Bernardo, your Chevy Volt, we think you got a flat tire, correct? And I was like, no shit, I got a flat tire, correct? So that was my first taste of OEMs trying to do IoT. And obviously, I'm a product guy, correct? I'm a UX product design guy by heart. And I was thinking, I didn't give him any credit, correct? I know how the thing worked, right? There was some signals in the car, and they came to somewhere, and that thing went to a cloud that was very secure, et cetera, went to whatever application and sent me an email, but that was not what I wanted to hear, correct? So if I play it back, the way it should have worked is that I got my flat tire, and then I would have gotten an application that said, Bernardo, you got a flat tire. And don't look for the spare tire because there's no spare tire in this car. And by the way, there is a couple of trucks that are available. You want one of them to pick you up. And there are a few tires that I recommend. Choose a couple, and I have them waiting for you in the tire center, whatever. So that didn't happen. So if you think about the OEM perspective, they deploy this technology, and actually, as a customer, I didn't give them any credit for it. So if you're on the side of the OEM that had to put capital to work against the solutions, they would say, the ROI, no big deal. We did IoT, we told Bernardo he got a flat tire, and nothing happened. There's no loyalty, he's not happy. So one of the things that I want to put in front of you is that the idea of being able to build this technology is not enough. We have to find applications that are useful for the customer. Only if it solves a significant problem, this will have enough push in the market with enough capital behind it to be a reality. So anyway, with that story in mind, that was my first introduction to IoT in automotive. So I work in JD Power, and JD Power is a company that for the last 50 years has done a tremendous job at talking to customers, asking them a bunch of questions in a very scientific way, and at the end come out with some insights that are useful. They're actually very useful for OEMs or companies like telco companies, banks, et cetera, et cetera. If you ask, I heard about this, and I'm going to accept that it's truth. If you ask Toyota, for example, why you've been successful in the US, some of the things they will say is because of JD Power. Because we ask people about how the driving experience in the car is, and we tell OEMs, or we tell auto manufacturers how to build better cars, the comfort of the seat, the way the entertainment system works, the way the transmission works, et cetera, et cetera. So for 50 years, we have done that. We call that stated research. And we ask people questions. They tell us what they think. We bundle them in a very smart way, and we tell people what to do, correct? So one of the things that we're doing now is moving away from, not away, in addition to stated research, we're looking at behavioral metrics and operational metrics to give us insights on how companies, how brands can build better products and better services. Okay. So I'll talk to you a few slides about that. What are we doing with cars? We have stated research. They have taught us a lot about how to build better experiences for customers in auto, what drives the driving experience. And then on the left is all this new data that's going through vehicles. And what we're trying to do is pair those data from vehicles to what customers feel drive their experience when we're in their car. So we started an initiative about a year ago to start looking at cars. Obviously, if you have done this before, it's a little messy. You have CAN buses in cars where you can actually read what's happened there. But it's not like a standard that you can just go somewhere in an OEM catalog and just get all the data. You have to start really playing a lot with, this is a particular OEM, for example, sorry. It's the OEM and the signals and all the car models. The columns are models and cars for this OEM in particular. And then on the left shows all the signals that we can read and not read, correct? So we've been doing this for a long time now. We have a lot of maps done. So we're ready to read signals. Awesome. So what do we do with it? This is something simple, correct? So we look at a bunch of cars and a bunch of cell phones as people work at them, correct? We do benchmarking across a bunch of cars. And if you see this, correct, if you're phone B, on the y-axis, it talks about problems per 100. So phone B has a bunch of problems reported, so meaning the phone is a problem. Now, in the vehicle brand Y, you see there's a lot of problems irrespective of the phone that you have. So I don't have to ask somebody that has a vehicle brand Y, what do you think about your Bluetooth pairing? They will say, typically sucks, correct? And I don't have to ask people in the other brands because they say, yeah, relatively works, correct? So, and I know, for example, if I am brand, let's say X, I know that the problems being reported are mostly because the phone B has a problem, not because I have a problem, correct? So we're starting to look at those signals to be able to go to a very fine level of granularity in terms of understanding the behavior of drivers and cars. I'll give you another example. This is about automatic braking system. And obviously a lot of cars now, most of the cars, new cars are just coming with this functionality that as the driver is approaching something that is blocking or that's standing, it automatically brakes, correct? And this shows a curve of the vehicle speed. On red is the automatic braking that happens with the car, correct? And the blue is the driver's braking. So this shows that probably the driver started to brake, but then the automatic braking came really strong and broke even faster or stronger than the driver. So we can do this at a car level. We can do this across OEMs, across brands, across models. So if you do it at scale, you start to understand how these systems have been designed and how effective it is. And I think this is really critical. And the reason is the following. When you design the systems, you have to make a decision on what the algorithm's output is going to be, correct? You have to make a decision that the software is going to execute that says how fast does the car need to brake, eventually some cars, how fast do I need to accelerate, correct? If you ask people or if you see people with this reaction, some people will say the car broke just way too fast or not fast enough. It accelerated too slow or too fast. I mean, if you extend that to the whole mobility of the car, then you start finding that the algorithms are not perfect. They also depend a lot on the personality of the person. So it's almost trying to find what works for every person. The challenge in autonomous driving, which is these are just components of autonomous driving, correct? Braking, changing lane departure, alarms, et cetera, are just components. But the key challenge will be how do we design this car so that the user trusts the quality of the decision and also the action that it takes, the car. I think for the first time in history, and let me know if you have another example, but we have these opinionated machines, and we're inside those opinionated machines, we're opinionated human beings, correct? So we have these things that have opinions and takes actions on those opinions, and we, correct, that are sitting there also with opinions, but in theory, in the future, with no action to be taken. And how do you build trust between me and the machine, correct? So we're trying to understand with this, how does that play between the quality of the decisions that a machine makes and also the trust that it generates. And this language, this quote-unquote conversation that happens between the machine and the human It's very hard to get right, correct? Because it's a conversation around what the car does, correct? So think about you building an autonomous vehicle. What do you do to build that trust? How do you drive? Maybe for my mother, you drive slowly because she wants to take slower curves, for example, and little by little start incrementing it. Maybe you talk and say why you're making a decision. Some autonomous cars are having screens that show everything that they're seeing so that you can feel they got it, correct? They just got everything. I don't have to worry that they didn't see that person in the bicycle, for example. So pretty interesting. And this last example is a blind spot warning. Something similar. The throttle position in this case is red. The visual warning that flies in the car is blue. And the audible warning is the white one, correct? And what happens here is that the driver hears the signal, sees the signal, but accelerates. So is that what we expected the driver to do, correct? So if you do this thousands of times across vehicles, you start seeing patterns that allows us to give the OEMs some better insights into how to build better cars, how to build the systems better. One of the things that we do well at J.D. Power is to use benchmarking to provide insights across all a bunch of different businesses, brands, correct? So what we're doing here, we're deploying these solutions across different OEMs, different car manufacturers and models, so that we can understand these behaviors, so that we can help OEMs build better cars.
So have a seat. So I think, one of the things that's interesting about IoT to me, and we talked about this, I think, on the phone. Oh my goodness, thank you. But one of the things we talked about, the challenge with connected devices, connected things, in the old days, you could assess, customer service experience. You could say, do you like my washer? Do you like my TV? Now, and again, I kind of assert that in IoT, you don't really have a connection to the customer because there are multiple stakeholders. There's the guy that built the device, the guy that uses the device, the guy that owns the device. Yeah. In the connected medical example, when Pascal was talking about earlier, you have different beneficiaries or stakeholders around the data. How does that impact what you're trying to do now?
Yeah, so I think, we work with, the bottom line for us is that we need to measure what the customer feels about, in this case, the driving experience, correct? We're doing similar things that we're going to announce on the utility sector and also in the telecom sector, but we fundamentally, we have a role to play because we understand customer experience and we map the signals towards understanding or predicting customer experience. So with the OEMs, for example, with the car manufacturers, we work with different stakeholders in the car manufacturer ecosystem, including those that provide services to them. We have a partnership with Harman, for example, specifically on this area, to start measuring how easy to use and how effective is usage of the electronics and the navigation, et cetera, and the audio and the head units, correct? Pretty much very similar to what we did in digital for the last 15 years. So we did A/B testing. We knew exactly what's going on the website. How do we do it in a car, correct? Right. So how do we design better interfaces in the car? The issue with cars, and the previous panel was very effective, very, very good at this, discussing the infrastructure and the platforms that support cars and all the issues driving it, is that OEMs and many industrial companies, the hardware cycle has been coupled with the software cycle. So it's very hard to always keep and maintain a discipline of improving the software experience, right? So we're getting there with this over-the-air updates that soon will come in an effective way. Typically what we see is that most of the stakeholders, they have a very long lag time to react. So many of these solutions are like long-term plays. They cannot quickly iterate on what is the best driving behavior, for example. But yeah, so with time, the ecosystem will come and work more iteratively than it does today.
And it also occurs to me that, with gathering data from devices, you've got a ton of data. So how do we discern sort of the signal from the noise?
Yeah, yeah.
And what do you do with that? I mean, again, I'm sorry to always reference my friend Bill, but Bill gets how many data points do you get from a TV a day?
486 billion.
486 billion.
Yeah.
How do you turn that into something that's useful?
Yeah. So we
not that you're not.
Yeah. So we focus. So we have something, for example, in auto called IQS, right? Which is is a survey in which we have bucketed types of problems in the car. So problems about the infotainment system, problems about the transmission, problems about the autonomous systems, et cetera. And we have mapped driving experiences to those buckets. So we have the fortune that we can start with a use case and drive down. Correct? We don't tell the data, tell us a story. We know what is the story that we need to look for. So for example, in this example, so we know exactly what are the 4, 5, 7 data points that we need to read.
Right.
We also know the frequency in which we need to read them and how we can combine them to create an outcome and to create an insight. Because you have too many signals, correct? So you have to start refining what are the, you have to start finding what are the signals that you need in order to get specific insights. And it comes from just years of research on what drives experience.
That makes sense. And I do want to invite the audience in, and anybody that uses the word bumblebee is going to cost Wolfie $10. So I just want to, I want to remind her that she's still on the hook for, looks like about $100 now. But, jump in if you guys have questions. Again, the notion of, there's a lot of folks compiling lots of data. Again, Visio's got lots of data.
Yep.
How do you become the trusted provider of that data?
Yeah, so there's a big question in the industry about where's the data going to,
right?
And with the right reasons, the car manufacturers are being very cautious about sharing that data, right? We believe that we have a shot at being that party because we have been a trusted third party around customer experience for a long time. But it will depend a lot on use cases. For example, in the case of what I talked about in my car, correct, it would have been nice if they had provided APIs with certain permission and security to my insurance company, and they would have taken care of all the application layer stuff,
right?
Correct? Bernardo, we got you, your cover, here's the car, correct? So those are the type of things that need to happen.
And that's a multiple stakeholder issue,
yeah,
too.
But I think it will take a while for the industry to get comfortable with the secure around it. I think that we understand the technology, right? And in the panel before, I think one of the key issues on technology, barriers to technology, is the fact that the cars have a lot of legacy systems. If you can do it from scratch like Tesla, it's a piece of cake in terms of software updates and sharing. But the cars have a lot of legacy systems.
And average car ownership is what? Kristen, you would know this, 6, 7 years? 11 years.
11 years.
So,
and I just heard the previous talk that there's 100 million lines of code in a car. So there's a lot of, and anybody has worked in digital transformations and how to improve a company and how difficult it is to change legacy systems and coding, imagine that in a car, correct? So it's going to take a while until the systems are in place to provide a very open, flexible, and secure infrastructure in the car. So we're going to get there little by little. So the signals that we're extracting, a lot of it are very simple signals you can extract from the dongle. Right. And again, we're working with Harman to see if we can go directly and extract all the signals.
Perfect. Now, I know we have a question in the back. David?
Yep, thanks, Mark. So from an outsider's perspective, IoT seems to present a lot of bright, shiny objects. There are bright, shiny objects in the car.
Yep.
There are bright, shiny objects in the office, because I went to the smart office presentation earlier. I suspect there would have been bright, shiny objects to talk about in the Metropolitan presentation across the way. At what point is there going to be software? I'd rather, as a sort of an outsider or as a layperson, I want the sensors and all the intelligence to happen without my having to think and make any decisions. I just want magic to happen.
Right.
Like in a sense it happens in the car, but I want it to happen in the office. When is that all going to be brought together through AI or something else? Because right now there's too many bright, shiny objects, and this seems to be more of interest to technicians or technologists and less to me.
Yeah, cool. So I'm an engineer by training, so I used to do a lot of engineering stuff, and I fell in love with what was possible, correct? And we all engineers here fell in love with what's possible to do, and we forget what's actually useful. And so it takes, I think we need to really focus on use cases that solve a significant problem for, in the case of auto, either the consumer, the owner of the car, obviously, and then eventually also the OEMs. There's many use cases around preventive maintenance, et cetera, which are quote unquote, an easy way to find ROI. But I think the key will be on user value, and I think the key will be to use IoT, like we try to do here, to help car manufacturers and also suppliers of manufacturers to build better products, correct? Because if you ask OEMs, for example, how many of your customers turn off the automatic braking system, they will not know. How many of those turn off compared to your 10 biggest competitors, they will not know either. So it's very hard to build a better car if you cannot read what the customer is doing with the car.
No, makes sense. I know we have a question back here.
Yeah, so car makers, OEMs in particular, they invest quite a lot into infotainment systems these days. And I'm really interested from the consumer perspective because when you have, it's more about the graphical user interface of how the car communicates to you and how you communicate back to it. And I found that for me, for example, a smartphone itself is already enough to deal with most of the issues that I need when I'm in the car, and infotainment is unnecessary to a degree.
Yeah.
So I wonder from the consumer perspective, is this investment actually, it has ROI from the car maker manufacturing perspective as to why they do this?
Yeah, so I don't know the answer. I don't know if, Chrissy, you know the answer to this. Chrissy works with us as well.
I don't.
You don't? Okay, sorry to put you on the spot. But I mean, anecdotally, I believe that, that makes a lot of sense, but I don't know. The same thing that happened with GPSs, where people say, why do I need a GPS in the car? But I don't know the numbers.
See, I think the thing I'd add to your question, so you're in the network world, we used to call that tethering, where you always brought your own connectivity with you. The vehicles now should have their own independent connectivity, especially in terms of a connected car. So maybe from an infotainment standpoint, you bring your Apple Play, as we were talking about in the last panel, and or Android Auto, and it's a great experience, and you replicate and share your music or your other media files. Yeah. But I think in the case of sort of the connected car, the truly connected car, it's connected on its own, without your bringing in your cell phone. I mean, what if you don't have your cell phone, as an example? So you don't want to be dependent on that from a tethering standpoint. I think we had another question coming in.
Yeah, so I wanted to make two observations. There was an article in the New York Times recently about the op-ed said that they preferred to have a manual transmission because they felt it was safer because it connected the driver to the actual driving process in a way that autonomous driving and these kinds of driver assistance models are starting to break away from. And also, I just wanted to point out that you guys gave out the little webcam cover-up slides, which is like an example of building technology to undo what the technology company has done.
Yeah.
So I wonder if you could talk to sort of the other case, the case of developing cars for people who want to be the driver, who want to connect to their vehicle in a way that's particular and sort of unique.
Yeah, so I think that exists today, correct? So the question is whether the industry will keep doing those cars and whether the market is going to be enough, correct? But if there are cars, there are manual shift cars that will continue to be there because people like that experience, correct? But in volume, the expectation is that semi-autonomous and autonomous driving will obviously spike over the next 5 to 10 years. There's an issue about generation as well. I think that for people that are 30, 40 and over, they like driving a car. They feel like that's the way they should do it. But now there's a lot of question about should I own a car, correct? And should I own a car with 95% of the time the car is just sitting idle, right? And I think that progression will happen, ride sharing and eventually autonomous car. I think that autonomous car will be too expensive for a while for people to own. So there will be more in fleets than people actually own it and share driving, car sharing, for example. But I don't think that trend will shape. It will be a small share of the cars being sold, the ones that are really focused on the driving experience, the way you, for example, might enjoy driving.
The fine gentleman right here has a brilliant question.
You're putting too much pressure on me. So I think it's a great cue because with the sharing economy happening and the autonomous cars kind of intersecting with that, and the data that's being generated every mile, there's also a trend of customization of the car in terms of the passenger so that the experience is richer and whatnot. So you have this opportunity to leverage a lot of data, but with the ride sharing, with the fact that you're sharing the space with a bunch of other people, how do you see the evolution of this data sharing sort of happening in the sense that there's a fine line between customization and personalization versus all this data that's kind of mushed in a melting pot, if you will, right? Because that's where the biggest opportunity now is, where it's an inevitable trend, but how do you, giving the lens that you have,
the car drives?
or either that or just the experience and the preferences and
Yeah.
So is it like the creepy factor, like, again, Bill was talking
Yeah.
about?
yeah.
I think it's going to take a long time to get us there, mostly because the ability to iterate on the software and the algorithms in the car is going to take a while. Even now, correct, for the next 5 years, my God, is that cars will be making, we'll try to do an average behavior in cars, like an average way to do lane departure system, so it's like the least common denominator for everybody else. It will take a while until typically the car learns about you and start to react to that. It might require either some software in the edge that does that training, or software in the cloud that allows you to do an over-the-air update. So it's going to take a while. And I think that eventually you're going to have your own signature, correct? And when you get a car sharing, it will know it's you, and it will know the way you like to drive. The same way you speak now to a driver and say, hey, man, you're going too fast. You will check in, and it will know it's you. But it's going to take a while. And I think the biggest driver is this still coupling of software and hardware, and the fact that it takes a long time for OEMs to manage software in cars and make changes there.
Isn't it true that, if a new feature is introduced today, it won't actually see the light of day for, 7 years in a vehicle? 5 years? Again, Kristen, you were at FCA. So
4 or 5 years?
So it's hard to innovate when you're trying to predict the future in 5 years' time.
Yeah.
But I know we have a question in the back right here.
Yeah, quick question. Do you think the form factor of the car is going to change as they become more and more autonomous? Are they going to get smaller? Are they going to get larger? Are they going to get two-wheeled? Did you talk about that?
Good question. Can you answer for me?
Kristen says yes.
The cars are going to change shape, right? I mean, much of it's going to become, sorry. The cars have the potential to change shape. It's going to become much more of a usage-based model, and as such, you might have a car that fits one person just for a mini trip. You might have a pod that is a shared space. So I think that's part of the opportunity going forward, is recognizing that there are going to be multiple different solutions and the vehicle is going to look different. And if you don't own it anymore, then it can become that usage-based vehicle experience.
As I mentioned in my morning comments, we're here at the Media Lab. I think it's about 2 or 3 floors down. They have prototypes of vehicles that kind of expand and contract, kind of to Kristen's point, in one of the labs, actually sort of on this corner, as I recall. So I don't think you're far off, and they've been doing a lot of that work here for a long time. We had one right there. I know I saw a hand.
I have a question. I was wondering about what is the incentive for OEMs to provide you with data? So, for example, if I drive a Toyota, and Toyota, across the next 20 years, I'm a loyal Toyota customer, and Toyota can build a profile about my driving, my preferences, etc. I could become an even more loyal customer because Toyota could frame a car especially for my needs. Given having that in mind, what is the incentive for a company like Toyota to provide that data about me to a company like JD Power or any other company, such that are we looking at an environment where all of these OEMs are closing off access to their data, or a separate inverse environment where it's open data, share for all, and everybody can use it?
Good question. The reason we get data today from OEMs where they don't need to give us data is because of benchmarking. So they can understand fairly well your behavior as a driver in a Toyota and how the car reacts to your driving style, for example, but they cannot compare that to a similar person that drives a Honda or a GM or a Mazda. So as they design cars, they want to see, is this reaction that people are having on lane departure the same one, or are we doing something wrong? So they see others. So the trick for the business model for us, to be honest, is to be able to be a trusted party that allows them to trust that by sharing this data, they're going to get a lot more in return. Obviously, there are some things that we cannot tell others about their data, and those rules we respect very carefully. But enough, at the aggregate, we can tell them enough information so they can do even better than just looking at their own cars.
We have time for, I think, one or two questions, and there's a gentleman right here that I'm looking at.
And I'm wondering up here, you go.
Thank you.
There's been an effort by the Linux Foundation to set up a kind of common platform that provides the base for entertainment and other functions within the car.
Yeah.
So, and they've got, I think, about 20 or more auto manufacturers in the group.
Yeah.
Is that kind of common platform development or common software base going to make it easier to do some of these comparisons across different vendors?
Yeah, so eventually you can standardize the way data is presented and the way the data is accessed. But again, it will always be the OEM's decision on how to share the data and to whom to share that data. But definitely, the more standards there are, the better. You saw the slide that I had before. It is sometimes depending on the model make, on how the data is tagged. I mean, it's almost impossible that you can do a comparison of ADAS systems, advanced driving systems from between OEMs and models, because just the data is all over the place. There's a lot of groundwork to be done to have the data model normalized. Eventually, that will be a great thing for the industry. We can start standardizing the way data is kept, accessed, and the way the software runs in the car.
So it's all about the data. And we learned that this morning. We learned that, with our friend Pascal talking, about connected medical devices. What do we do with all of it, though? I mean, do you keep it all? Do you store it all? Do you throw it all out?
Oh, you keep it.
You keep it.
We have a lot of data, and we still keep it.
It's good if you're in the cloud business.
Cheap, man. I mean, data is storage is almost free, correct? So we have 50 years of data, correct?
Wow.
And this is a lot of data, and in a bunch of industries, right? In here, we're getting a lot of gigabytes per data per hour, and a bunch of things that we're doing, correct? So the idea is that when you ask about these use cases, obviously we look at these use cases and we try to be very narrow in the data fields that we get. But you can also run machine learning algorithms to just explore other types of data and correlations of data against this, correct? Or the predictors.
So will you go back in time? Will you, in other words, say, I want to run some sort of calculation on data from 30 years ago? Historical data?
Yeah, but we don't do it necessarily for now. I mean, we did it at that time, correct?
Okay. You could.
What happened a while time ago is not going to tell us much about a car right now.
Okay.
But we just keep the data for the purpose. Yeah.
Cool. I want to thank Bernardo. That's our time.
Thanks very much.